Okay, guys. So last session, integrity constraints, we started, and up to the rules we discussed. Okay, na? After making or created your relationships, okay, what kind of rules we need to check now? There are two rules are there. What is that? We cannot insert values into foreign key column which was not found in a primary key column of parent table. That is one thing. So that's why when I tried to insert 30, it was showing that parent key is not found. Second one is what now? Deletion rule. So deletion rule, what it was tell us, we cannot delete a row from the parent table if those rows are having references in child table without addressing to child. Okay, this is what second one. Now in this two, if you want to check it out, okay, the first rule, what is the conclusion of this first rule? It means that, okay, what does that mean here? So yeah, simply it was telling like that, the mean of this, no parent, no parent is equals to no child. Actually, the first rule is telling us if there is a no parent and there is no child, it's impossible to have a child without the parents. And now tell me, if I try to delete this, that otherwise I try to break up this rule, is it possible to break up this? Can I break this? No, because whatever the condition was telling us to no parent, no child, it means what now? There is no condition here. We can't go for any, okay, so what we called open. Open it. No problem, open it. Okay, right. So no parents and no child. So we cannot change this rule. Impossible. It's a fixed rule. So no parent, no child is a fixed rule. And there is no chance to have any changes in this means. There is no chances. Okay, right. So I just leave this rule. I can't break this rule. But come to second rule. What is the second rule? Deletion rule is there. Deletion rule, what it was tell us, we cannot delete a row from the parent when that row is having references in your child. Okay. And when I try to delete it, this one, what it was showing to me, whatever the department number 10 are you deleted from your department table. So the 10 is having what now? Child records. That's why you can't do this also. Okay. But point was, what's the point? What is the point of this here? So online students, check it out, guys. Am I audible? Online people. Okay. Okay. So deletion rule. Okay, we can't go for to delete here. Okay, because of reason. Leave it here. Leave it. What children's? Uh, like you're fighting like LKG, UKG students. Uh, professional courses learning, and you behave like this. Leave it that. Come out. So what we said, we cannot delete a row from the parent when the row is having what now? Child. So we can't do this, but there is a chance we have. What it was saying that we cannot delete a row from the parent table when we are not addressing. Without addressing, we can't do it. Okay. It means if I address to my child table, then I can do it now. Yes or no? So there is some chance we have here. Okay. So now the question is, without addressing, we can't delete a row from the parent. So it means what now? If I address to the child, okay, then I can delete my parent. But how to address her? Okay, write down below. How to address? How to address? How to address to child table? To child table. Okay, na? If we want to delete a row from delete a row from parent table, from parent table, from parent table, then we need to use use the following. We need to use the following cascade, the following cascade to to address to the child table, to address to the child table. So here two kind of what we called the rules are there. First one we called as here on delete cascade rule. So this is one rule, and the second one we called as here on delete set null rule are there. On delete set null rule is there. Okay, fine. So on delete cascade, what it was tell us? Okay, it means that so when we delete a row from the parent table, from the parent table, then the corresponding then this corresponding then the corresponding child rows are also deleted from the child table, automatically, from the child table automatically. So whenever you delete a row from the parent table, then the corresponding child rows also are also deleted from the child table automatically. Because simple reason, no parents, no child. So that's the parent is delete, the corresponding children is also deleted. Okay, right. So how, sir? So how to implement this rule is here. Observe. Don't write. First observe. Yesterday, the normal example we taken out to create your what we called relationships in between table. So the same scenario I'm taking, but the only the thing is I want to change my table name here. So whatever you want to do, you have to change this. Okay, right. And everything will be same now. Now here, every table must be unique. So that's why I'm taking DEPT2 and remaining all the things are same. Next year, few records I'm inserting into this table. Okay, the remaining things are same. Next, EMP table, the again unique name, but this time this table, okay, I'm taking references from DEPT2, and now on this you have to apply your on delete cascade. So on delete cascade, I'm going to apply here. Okay, and remaining the things are 2, 2, 2, and 2. Okay, now this is what. Let me go and check it out one by one. I just go to check it out now. So the parent table successfully we designed. And now you want to insert your first record, the same as second record also I'm inserting now. Okay, I just made it commit to permanently save. And later the reference table, that's called a child table. The child table is also I'm going to taking now. And now here child table I created with which reference? On delete cascade reference here. Then after you have to, okay, insert your records like 10, 10, 20, whatever you want. But those values must be there in the primary key. So 10 is there in the primary key column in your parent table. So that's why it is accepted number of times. And we all of you know this, a foreign key by default accepting duplicates and nulls. And this is also I just committed. After committed, let me come out and see your finally two tables was got it, your DPT number 2, this is your data, and EMP number 2. Okay, so the parents are 2, children are 3. And now here 10 Oracle parent is having how many children's? 2 children's. Java parent is having how many children's? 1. Okay, now you can see. Now on this table data, if I'm going to applying delete, so delete from what is my parent table? DEPT2, where what I want to say, DEPT number is equals to 20. Suppose if I just try to delete 20, but actually what it was happened, the 20th parent is having how many children's? 1 children. So now we can see I'm execute. But the same thing yesterday I did, but yesterday it was showing error. But now today we successfully deleted a row from your parent table. Okay. After deleted, you just come out and check it out here. So deleted, yes. And the corresponding child deleted, yes. So parent delete, child also deleted. Okay, now right on. So after deleted, then you can take your DPT2 and EMP2. Right now. Completed. So in this case, what it was happened, once you deleted parent, automatically the corresponding children's also deleted. This is one thing. And the finally you see this, okay, I deleted 20. So now 20 was not there in the parent table. So parent row successfully deleted. And the 20th parent children's, the corresponding children's also not there. This is one way of this. Okay, when you don't want it parent and child. Okay, then you can use or apply this. What is the next one here? Sometimes what we want to do, I want to delete a parent, but I don't want to lose my child. Okay, in that cases, we want to go for what now? On delete set null. Now take second one. On delete set null. In on delete set null, what it was happen when you delete a row from the parent table, then the corresponding child rows, rows of child rows of a foreign key, child rows of a foreign key column values are converting values are converting into nulls, converting into nulls, okay, in child table automatically. Okay, so here the same thing, what we did for your on delete cascade, the same thing I just go for on delete set null. And here also every table should be have a unique name. Okay, so DEPT3 I'm going to changing here. So here also DEPT number 3 and now EMP3 and taking references from DEPT number 3. And what is my okay rule is what now? On delete set null. Okay, then after as usual 3 you can insert some data into this table. So now here previously whatever we did here, now we can see. Suppose I'm just going to execute this department table. Okay, the same thing I inserted here. So I created and later I want to insert some data into this tables now. So now insert your two departments details I'm inserting here. Same as usual, I need to commit this. And later, the next one, okay, on delete set null, I was applied in my child table and child also successfully created. So then after we need to insert few records into this your child table. So now if I go for, okay, the two records I'm going to insert now. And this is also I just go to do commit. After committed, you can come out and see your table information. So select a star from my parent table is what now? DEPT1. And now the parent table is child table is sorry, DEPT1 or DEPT3? DEPT3 and now EMP3. EMP3. So again, now we can see. Now I'm deleting from DEPT number 3. So where DEPT number column basis is called a 10. I'm going to delete. Something is missing. Delete command. Okay, right. So deleted. And after deleted, let me come out and see what DEPT table. Okay, deleted. Yes. But come to child table, what it was happen, you can see. So child table foreign key column values are converting as a null. So now we can go to execute. Now the corresponding value. So here 10 is deleted, but the 10 child was not deleted. The data will be there, but only the reference column value will convert as a null. That's it. Okay, no, but not a delete. Right down below. Take this. Okay, completed. Mm. So these are on delete and on delete set, on delete cascade. And remember one point that these two rules you cannot apply on same column. Same table, same column, twice. These two things are we can't use it. Any one only possible. Okay, na? Right. So these are the two tables relationships. For example, you have a question, sir, I want to make the relation more than two tables. How we can? Okay, no? So it's a depends on requirement basis. You have to create any number of tables to relationships. Okay. One example I will explain to you. Careful observe. Okay, now. So the make it here. How to create a relationship between more than two tables. Okay, your requirements observed. What is the requirement of client? Okay, na? The requirement is to make a relationship between customers, products, and orders tables. So this is my requirement to make a relationship between customers, products, and orders. Okay, now? Right. So first of all, I'm going to analysis this and I will explain to you along with your diagrams. After that, you need to implement. Okay, now? First, don't write, observe. Did you, anybody knows ER diagrams? Did you listen ER diagram? Listen or not? So now, in real time, ER diagrams, how they will be go to preparing. How they're going to be preparing your ER diagrams as per your requirement basis. Okay, na? One small, as per my requirement, customer product orders. These are the three tables. Based on these three tables, now I want to prepare one ER diagram now. So I will prepare here ER diagram. So ER diagram, okay, stands for what now? Entity relationship. So ER diagram on which table? On which table? Customers. Comma. What is that? Products. And orders. Orders tables. Okay, na? So now this is careful observe how in real time the people are preparing your ER diagrams as per client requirement. Okay. This is my diagram now I'm preparing. So in this diagrams, we need to make it some symbols, rectangle symbol, oval symbol, rhombus symbol, arrow symbols. These are the important for us. Rectangle symbol is representing entity. Entity is nothing but table. Okay. Ovals, whatever we are representing, those are fields. It's nothing but attributes. It's nothing but columns. Whatever the rhombus, it was showing that this is called a relationship. The making what now? Relationship. Okay. That is what? Arrows will showing as a flow, connectivity. flow or connectivity. Okay, now these are the common symbols. So now first of all, as per this requirement, so in this three tables I'm using now, if you understand this logic, same as you can do 4, 10, 20 tables also. Okay, so that's a careful focus. First of all, I'm going to preparing some entities now. So this is one of my entity. Okay, this entity, okay, name is a customer. The entity name is what now? Customers. Okay, now this is my entity. In this entity, I'm preparing some fields. That means this entity, what should it was having? What kind of fields are having here? So that every field I'm taking with some arrow marks here, some lines I'm taking now, and it's your wish. You can take any number of attributes. The first oval to me, and this is one more oval I'm taking. This is one more, and this is one more. So in this, my first one, I required a customer ID number is required to me. Okay, na? Next, I want it here, customer name. I want it. Next, I have to here, customer mobile number is required to me. Next, I have to here, customer address. I want it. These are the some fields I'm going to taking now. Same as another entity I'm going to preparing here. So this is one more entity. This is one more entity and having some fields. Okay, having some fields. But it is not like that your rectangle is having 4 corners. That's why 4 fields that I'm taking. Not like that. It's a depends on your requirement. If 4 fields are, 10 fields are, 20 fields are, it's your wish. Okay. So now here, now I will go for this. So this table, I'm going to taking what now? Products. This table, I'm taking what now? Products. Okay. In this, some fields I'm going to taking now. This is one field. This is one more. And this is one more. In these fields, what it was, what I need to keep in this here, definitely have your product code, and definitely we have your product name. Product name I should be required here. And now here you have it. I want to take your product name. So product name. So this is one more we can go to take now. Okay, na? Right. So product name and product code, whatever. Next, we have here one more that is called as what now? Price. So price is one more column I'm going to maintain. This is one table. Okay, right. Now another entity I have to prepare. So this entity is called as a orders. In orders entity, what I required means I need to maintain some, okay, order ID number, the order date, quantity, okay, how much you want it. Next, you want it one more, and you want it one more. So what kind of attributes I need to maintain in this? So I want to maintain here okay, what I required in this orders. So now you have to require my order ID number. I want to require here my order date, on which date customer is order your products. And I want it here, okay, the reference of customer ID number. the reference of customer ID. I want here the reference of P code, product code reference I'm taking, and I want to order here. So what I want to take now, so quantity. Okay, now this table is what we called orders. So this is my table. Now, after making this, now you have to prepare your relationships. And the relationship I'm going to taking now. Okay, the rhombus symbol I'm using now. Let's make it your relationships. And to whom relationship is having, guys? Customer to orders. Customer to products. Products also you want to view now. First customer view the products, then he will order. Okay, so that means the relationships are like this. So here it will be having one more. Okay, and here this is not a relationship. This is just a contains. Now, what is my requirements here? Observe. Customer will go to take a order. That is, who will be place order, guys? Who will be place it order? Huh? Customer. Customer place orders. Orders contains products. Orders contains products. Okay, na? So this is what it was. Otherwise, I will take this arrow in place of this normal I'm taking. Okay, better it is, and looking good also. So now okay, na? Right. Then after right. So now I want to take arrow marks. Okay, right. Here, okay, the relations, how it was means, here this is the relationship. The relationship is representing with the symbol of, what is the symbol that is? Rhombus symbol. And now we can see what I'm saying here, customer placing. What I'm saying here, customer placing. What he was placing? Customer placing order. Orders contains, order contains products. Products are viewing by, who will view? Customers. Okay, right. So your view is not a relation. View is not a relation, but placing is a relation, contains is a relation. So this is what the real time, when any requirement is come to the people, any client requirement or any requirement, the first the people will analysis that requirements, how many tables are needed for this requirement, each table, what kind of fields we need to mention, which table to which table we need to make a relationship. Okay, now the making of relationships, primary key, foreign key, how to use. Okay, this all they will be analysis. Along with analysis, they will go to draw a picture. They will go to draw a picture that is called a ER diagrams. After drawing is over, the pictures are completed. That means your client information or client requirements, which format? Text format. My client information is which format? Text format. Text format of information will be converting into pictorial format. Which format? Pictorial format. That pictorial format is this. Now this pictorial format, now I need to practically implement. Understand now? So analysis, designing, development, testing, maintenance is called as what? What we call these phases? Analysis, designing, implementation, testing, maintenance. These are the SDLC, software development life cycle phases. Okay, now? So now analysis diagram we prepared. Now what we want to do? Implementation. So practically I have to implement it. So whatever the diagrammatical format is there, the diagrammatical format I need to implement now practically. After implementation, what we need to do? Test. Okay. What is the testing here? What is my testing? Suppose customer orders products. Okay. That means customer details I need to save. Product details I need to save. And order details also I want to save. Understand now? So that's why how many tables are required? How many tables? 3 tables. One table customer I'm using for customer data storage purpose. One table product I'm using products data storage purpose. One table orders. Order details are storing purpose. So total how many tables we required in this project? 3 tables required. So 3 tables I need to draw. With how many columns? For example, customer table with how many columns? 4 columns. Orders table, 5 columns. Products table, 3 columns. Is it clear? Now, that is the columns we have to design. After that, the relations I want to place. Relations when I want to place, we require a primary key and foreign key. But in this diagram, can you tell me which table is primary key, which table is foreign in this? Customer is a primary key table. Okay, next. Product table also. Product also primary. Product foreign. Check carefully. Customer is a primary key table. What about product? Check once. Check your orders table is there na. In orders table, which columns are you taking reference? What is the reference of customer? Customer ID. What is the reference of product? P code. So that means your references these two na. These two are you implementing which table? Orders. This reference is taking from which table? This reference is taking from which table? Products. Is it? So now this is foreign key. Now foreign key, how many foreign key columns in my orders? 1 now. 2 foreign key columns. First foreign key reference column, CID. Second foreign key reference column, P code. Now tell me, finally, how many parents? 2 parents. How many children? 1. This is called as what? 1 to many. Or many to 1. Okay. So this is what we call as many children or many parents, 1 child. 1 child, many parents. Like you can go to define. Okay, na? So now this is the information. Finally, testing. Implementation I explained. Testing. What my testing in this case is? My testing is what now? Suppose orders, when you will be take order, from the customer? See, suppose I'm going to order some products. When I will be ordered? When stock is available. Very good. Stock is available. If stock is available, then customer will go to order. Those order details I have to store into orders table. Suppose stock is not available, but customer is there. Can I take order? No. Order when we want to take? When customer should available, stock is also available of particular product, then we are taking what now? Orders. Is it clear? Huh? Suppose if customer is not there, product is available, can I take order? No. Customer is available, product is not there, can I take order? No. So that means my testing area what now? Once customer deleted, the customer orders also deleted. Once a product is deleted, then the product customer order details also deleted. So testing is what now? Which case? On delete cascade is suitable? On delete set null is suitable? On delete cascade. So on delete cascade, what it was telling? Parent delete, child also delete. So that means in this implementation, which cascade rule is implemented? On delete cascade. So testing, understand now? What is my testing? Once customer data delete, that customer order details also delete. Once product is delete, that product order details also delete. So that means what do you understand? Final conclusion: no customer, no order, no products, no order. When I want to take order, when customer is available, products also available, then I will take a order. This is my testing. So implementation, testing, I explained. Okay. Finally, what you have to produce? Maintenance, result. So that result you give to me. Huh? Can you try this example? Draw first this diagram. If this example, if you've done perfectly now, then you will understand normalizations. Easily you can understand normalization, and you can easily making relationships in between any number of tables. Once this logic, if you implement it. First to draw the diagram, right? Notes. No. These symbols are what? Hmm? That symbol is an entity. Remove. Symbols also having meaning. It's not like that I wish I will write any manner. Okay. Every symbol is having some meaningful here. Table's purpose, rectangle only use it. You can't use other than rectangle for table's purpose. Columns purpose, oval symbols only use it. You can't use other symbols for here. Relationship purpose, rhombus. Other than you can't use here. Okay. Clear? Implementation, testing, output. These three I wanted. Tomorrow. Will you show it? Huh? So expression clear now, all of you? Your duty is what now? Implementation. How I was implemented here? Step by step, neatly. Okay, now? How we implemented? Parent table, then inserting data of parent, second parent table data insertion, third child table data insertion. This is implementation. What we need to test? Delete command test, because insert command no need. Which rule you have to test? Deletion rule. So deletion rule with which cascade rule? On delete cascade. So once I deleted customer data, then orders will be dropped. Once I deleted product data, then product details orders also drop. When both are available in my tables, then take order. If anyone is not there, don't take order. That is my conclusion. Okay, na? So like that, you have to implement, test, and show me output clearly. Okay, na? Is that clear now? Okay. So tomorrow I will say that. Okay. Right, guys. And I stop it here. We'll continue tomorrow. Okay. All right. Thank you.